Good afternoon. Right. So today, so now remember we have finished the officially the data representation, but I told you that we are going to do a small part which is not in your syllabus. But in case they ask, we are going to do a small part, but that will be do after starting the digital circuit part. Okay. So that is topic number 4. Uh, so our next topic is digital circuits. Right. Digital circuits. Topic number 4. Okay, topic number 4. Uh, Analyze basic digital logic gates in terms of their unique fundamentals. So we are going to look at some logic gates and so on. So then simplifies logic rules, logic Boolean algebraic rules. There are about 20 odd rules there. And then designing simple digit circuit for using logic gates. And then we look at some useful combinational circuit components and uh, sequential circuit components like latches. So then your syllabus is over. So these are the flip-flops and so on, the last sequential circuits, okay? Right, so this is a very important topic because every year you have a second paper question. So this is the first time so far we have covered 3 topics, but all these 3 topics you don't get second paper questions, only MCQs and occasionally structured essay subpart, not question. But this is our first topic where you have second paper guaranteed. There's a second paper question, second paper part B question, essay question. Okay, so that means now we are into the very serious stuff. Okay, very serious stuff. Uh, right. So I have enabled the first note for your this subtopic, Boolean logic. Okay, so then you have the digital circuit design. Other nodes I have not enabled yet, the combinational circuits and sequential circuits. Okay, right. I have enabled only 2 nodes, introduction and digital circuit design. Okay, right. So let's start with introduction to Boolean logic. Okay, so I'll be referring this particular node. Okay, so I'm doing this topic little bit slowly because this is the critical topic. So in A-level ICT, if someone asks what is the most important topic you have learned, of course, if you want to have career in IT field, I have no doubt that is logic. Okay, that is logic. Right. So why are we interested in logic? So first of all, you must know why are we doing this topic, right? I told you this is one of our serious topic. Why? So there are 2 major reasons. Number one is directly related to computers, IT. Number two is related to your life. Okay. So why are we interested in logic? If I give you the answer related to IT field, remember computer represent everything as binary digits. That is why we did representing data in the computer last class, last 3 classes. So why do we represent data in the computer? Because we want to process data. Computer is a data processing device. So then someone will ask, how do you process data? By applying Boolean logic. So how do you process data, or how does computer process data? By applying logic. So if computer is a data processing device, IT field is all about data processing. So this is the most important topic. Okay, simple as that. So without understanding logic, you will never understand what is how the computer process data, what is how to write computer programs, and so on. So the second reason why we are interested in logic is second reason. It's nothing to do with IT field as a human. As a human. So remember, not everyone has the same kind of a life. So we have different people. Some people are wealthy, some people are not wealthy, some people become little bit stupid, some people are very intelligent. Okay. Some people become engineers, doctors, some others, they can't go into that kind of a level. So what determine those? One of the key factor, I can't say except if only factor. The most influential factor is their capacity of logic, logical thinking capacity. So if you are a very high logical thinker, you will end up in very good profession, right? Not only profession, right? You will end up being wealthy because you know how to make money. How okay. So therefore, this is you the most important subject for both your IT career and your life. And remember, as humans, we are also animals. We are animals, right? Just like dog, cats. But only thing is, humans rule the world, right? Humans rule the world. So why we rule the world? We are not the strongest. We are not the biggest, right? We are the most logical thinking, right? Our logical thinking capacity as humans is superior to any other animal. So therefore, and humans rule the world. So likewise, so if you, we, among humans also, human society, who rule or who take control, who take the leadership in the society, because we are all humans now, who take the leadership, who take the control, the most logical thinkers. So if you are the most logical thinker, there's a high chance you are the leader. Just like as in general, as humans, we got the leadership in on earth. So therefore, this is super critical subject. So think beyond your field also, right? Think beyond the field. But at the same time, let's learn related to the IT field as well. So again, I'm telling you, in your A-level ICT syllabus, this is the most important topic, section 4, nothing else. Okay. And if you become a good logical thinker, most of the other topics are going to be very easy. Not only those topics, your life is going to be very successful. Okay. Right. So, so let's start with what is logic. Right. What is logic? What is logic? Because our subject is digital circuit. Digital circuits are all about logic processing. So therefore, we can't understand digital circuits without understanding what is logic is. So what is mean by logic? I told you those who are better at logic, they rule the world. So logic is scientific way of reasoning. Or we can say logic is how you reason out. How do we reason out? Right? How do we reason? So that is called logic. Okay. Correct. Now you must be able to give example. So just you can't give a definition and run away, right? You need to give examples and explain that your definition. For example, someone will say something like this. If you smoke, you may get cancer. So that is a logic, scientific logic. Right? If you smoke, you may get cancer. So that is logic. Okay. Someone will say, if you hit me, I will hit you back. It's a logic. Right? Someone will say, if you harm the dog, dog will bite you. It's a logic. Right? So logic is how we reason out things. Okay. How do we reason out things? So it's something like If P, then Q. If you harm the dog will bite you. If P, then Q. If you study smart, you will pass the exam with lot of ease. Logic. Okay. If you drive fast, you may get into accidents. Logic. So because of P, Q happens. So that kind of a statement is a logical statement. So this is how you write it. If P, then Q. Or you can say P implies Q. Because before start learning logic gates and so on, right? If you don't know what is logic is, you are very helpless, right? So remember logic is used to reason out. So then different people use different reasoning systems. But what we learn is formal logic, which is part of formal science, just like maths, computer science, those are part of formal science. So formal science is formal and scientific. We can prove, we can provide evidences, right? Then there's something called informal logic. Informal logic. Beliefs, myths. So those are not scientific. Those are not scientific. Someone will say you failed your exam because you did not study smart. So that is formal. Someone will might say you did not pass your exam because maybe you are unlucky. Right? You are unlucky. Your horoscope is not good these days. So those are also reasoning, right? So if reasoning, it is logic. But that is not formal logic. That is not we are going to learn here. Right? That is not what we are going to learn here. We are going to concentrate 100% formal logic. And why? Computer, that is one of the reason why people love computers and like to get things done by computers rather than humans. Because computer operates 100% on formal logic. 100% on formal logic. Computer doesn't process data using faith, luck, ghost, right? Liking and so on. So formal logic is formal scientific. And those are not opinionated, right? We call them subject, not subjective, objective. And we use those formal logic in science, engineering, business, like doctor take decisions using formal logic. Doc- but if you are astrologer, so he or she is not going to use formal logic. Doctors, engineers, scientists, entrepreneurs, most we take formal logic. But there are some people they take informal logic, right, to make decisions. So that is, but anyway, we are not going to cover this because that is then this is not science subject, technology subject. We are in science. Okay, so that is what logic is, and we are interested in formal scientific logic. Right? So as I told you, why should we learn logic? Because number one, yes, it's used in computer. Microprocessor has millions of logic gates, millions of logic gates. So other than that, you will be a good logical thinker, critical thinker, and you can apply logical thinking in whatever your professional area, whether you are a doctor, engineer, accountant, entrepreneur, businessman. So this is the super critical subject. Okay. So you will be a logical thinker if you learn it proper way. Otherwise, you will ended up as an illogical thinker. So logical thinkers, their decisions are very reliable, right? They are very reliable. So there's a better chance of achieving objectives, high quality, right? Illogical thinkers, it may work, it may not work, you may miss it. Okay. So same thing apply for the exam also, right? So if you are illogical thinker, you may mess your exams also. But if you are logical thinker, there's a high chance you will pass it with lot of comfort. Right. So remember, we are only interested in formal logic. So formal logic also, there are some branches. Formal, scientific logic, right? But in your A-level ICT syllabus, we are only interested in Boolean logic. We are only interested in Boolean logic. But Boolean logic is not the only way of formal logic. Especially if you learn about AI, you will learn some other branches of formal logic. Okay, like probabilistic logic and so on. But in your A-level ICT syllabus, we 100% because you don't have AI as a topic in your A-level. Usually AI is studied in university level. So we will be 100% concentrating on Boolean logic. Okay. So therefore, from this point onwards, our subject is Boolean logic. This entire subject. Okay. Right. What is mean by Boolean logic? So by the way, how do we get this name Boolean? Boolean was a mathematician, logician, English mathematician, British mathematician. So he contributed heavily to this field. So therefore, as a credit to that guy, we now call this Boolean logic. Right? Another name for Boolean logic is propositional logic. Right? You will understand why we call it propositional logic also, but it's most popular as Boolean logic now. Okay. And there's another interesting thing I want to mention. Right now we have so many independent countries, but you know that about 100 years ago, 100, 75, 200, 300 years ago, there was something called colonialism. Right? For example, even Sri Lanka was colonized by Portuguese, Dutch, and then English. And out of those, for the French colonized some countries, Spanish people colonized some South American countries. But the most successful was English people. That is why we are having this class also in English language because English is the language for education, language for business, language of the internet, the international communication language. So have you ever thought why that happened? There are hundreds of people speaking hundreds of languages, but English dominated, right? So if someone asks why, the famous answer is because English people colonized the world. But then what about other people? Dutch, Portuguese, French. So they also colonized. But ultimately, English people managed to take the dominance. So I told you, those who know logic take the leadership. Simple as that, even today. Right? So the leaders are logical thinkers. Followers, underdogs are those who can't think logically as much as good as the leaders. So no wonder English is the most dominant language in the world, the most dominant culture in the world. So Boolean is an English person. And most of the names that you encounter in this subject I list down Boolean, Venn. Have you heard Venn diagrams in sets? De Morgan. So we will discuss about De Morgan rule and so on. These are all English people. English means British, England, English people, English speaking people, English. So basically, Boolean logic subject and logic subject was mainly built by English people, heavy influence, and no wonder they dominated because those who know logic rule the world. So no wonder English is the dominant language in the world. If rather than Boolean, here we have something like a German or French person name. And if these dominant people are French or German, definitely now French is dominating the world, or German dominating the world, or Russian, or Chinese, or Japanese, but not none of those, but English. You will find that logic subject was biggest contribution came from British people, and not only they influenced the Boolean logic, they took advantage of that also. So that is another reason. When remember when we discuss about the history of computing, right? So most of the names were British. Then USA. USA is now English, right? Mainly British people colonized USA, America. One, right? Someone like father of computer, Charles Babbage, Ada. So those are all English people, and American, all those products are English people. So therefore, this is super critical topic. Okay. So if you want to take control of your life, learn logic. Simple as that. Right. So difference between Boolean logic and probabilistic logic. Both are formal logic. Both. But Boolean logic is two-state logic. The result of when we apply Boolean logic, always the result is either true or false. Or we can say yes or no. Or you can say one or zero. Or pass or fail. It's a two-state logic. So therefore, it's very simple, not very fussy. It doesn't mean that we can apply Boolean logic everywhere. No. But we can apply Boolean logic so many places. And whenever we apply Boolean logic, if we can apply, it's very reliable. So that is why we are really interested in Boolean logic. But as I told you, there are situations Boolean logic is not good enough. So that is where we have another type of formal logic called probabilistic logic. It can have multiple values. In between yes or no, there can be other situations like it's happened probability of 80%, but there's a 20% probability it won't happen. Something like that. So that is why if you want to study AI, artificial intelligence, your one of your biggest topic or subject is maths, probability and statistics. Because AI heavily depends on probabilistic logic. Okay. For example, think of a self-driving car. It's AI, right? AI based. It's not programmed like using Python or Java. Okay, you can use Python, that's a different story, but not in the conventional manner. Let's assume the car is now remember this is a self-driving car. The car itself drives. When there's a kid or something, there's a person, right? Say it's not. So there's a probability that this guy will cross or not cross. So this self-driving car need to decide that. Not only self-driving car, say you are driving the car, so you know that there's a possibility, right? So you need to guess it. Guess it. So that is why you have the intelligence. And you also use probabilistic logic by looking at the person, area, and so on. And also you need to take precautions because you know that even there's a slightest possibility. But if you feel like it's highly probable, you will take more precautions. Otherwise, you waste your resources, right? So you need to take those calculated risk and decisions. But that is probabilistic logic. Right? But we are only interested in Boolean logic or two-state logic. Okay? Two-state logic. Another name for two-state logic or Boolean logic is propositional logic. Propositional logic. So why do we call it propositional logic? Of course, Boolean logic as a credit to that person, mathematician. Propositional logic because it's based on propositions or propositional statements. Right? So what is mean by propositional statement? Because we can apply Boolean logic only to propositional statements. Okay. So then what is mean by propositional statement? So propositional statement is a statement which is either true or it is false. I'm not saying statement which is either true or false. No. Either it is true or it is false. So that means 100% you should be able to say that it is true, or 100% you should be able to say that it is false. So then that statement is proposition. If you can't tell it, or there's a possibility, 10% possibility of have true, 90% false, so then it is not a proposition. Then it is not a proposition. Right? Is it clear? Now you must be able to give examples, some examples for propositional statements, some examples for not propositions. So if there's a statement which is 100%, you can say it's true, or you can say it's false. It's a proposition. Like, for example, I can say sun rises in the east. Is it a proposition? Obviously, yes, because sun rises in the east. I have never in my life, I have found that sun rises from the west. So it's a proposition. Okay, proposition. There's nothing called some days sun rises in the east, some days it rises from west. No, there's nothing like that. So another example, say 5 plus 2 is 8. Is it a proposition? Yes or no? Anyone? Proposition or not? 5 plus 2 is 8. Is it a proposition? Answer is, or not sure. Answer is, it's a proposition. Yes, it's a proposition. Why? Because this is false. This is false. If something is false, it's a proposition. And we know that 5 plus 2 is not 8, 5 plus 2 is 7. So therefore, this is a proposition. Right? If you can specifically say using your common sense, logical thinking, scientific knowledge, something is true or something is false, it's a proposition. But you can't, or in general, no one can come to that conclusion, or it can happen, or not happen, right? So then it is not a proposition. So this is proposition because it is true. This is proposition because it is false. This is proposition because it is false. Okay? Because otherwise you learn all the logic and you don't know to what kind of things you can apply. So then you will think that you can apply it for true and false. So what is the purpose of playing true and false? We play with these kind of statements. Something like you get discount when your total bill amount is greater than 10,000. So that is logic. Right. So these are some examples of not propositions. Questions are not propositions. 5 plus 2 is 7 is proposition. 5 plus 2 is 10 is also proposition. But if someone asks, is 5 plus 2 7? That is not a proposition because you are not giving a statement. You are asking a question from me. If someone say London is the capital of England, yes, proposition. Paris is capital of England, proposition because it's false. But if someone asks, is London the capital of England? That is not a proposition because questions are not propositions. Okay. And also, if a statement can be true or false, depending on the situations, it is not a proposition. For example, 10 is odd number proposition. 9 is odd number proposition, but x is odd number is not a proposition because we don't know what is x is. Because if x is 5, this is true. X is 6, this is false. So it can be true, it can be false. So therefore, this is not a proposition. Say x is greater than y, not a proposition because it depends. Right? If these are 5 and 7, this is false. But 8 and 5, this is true. So that means depending on your xy values, this can be true, this can be false. So then it is not a proposition. But definitely 5 greater than 7 is a proposition. Okay. So what about this? X is a real number. Real numbers are the numbers that we use in day-to-day life like 10, 12, 3.5, -2, -2.85. Say x is a real number, x squared is greater than or equal to 0. Is it a proposition? Yes or no? Yes or no? Don't worry, your answer may be wrong. That is why you are here for this class, right? Otherwise, you will not attend the class, right? If you know everything. What do you think? This is a real number. That is numbers that we use in maths in day-to-day life. X squared is greater than or equal to 0. Proposition no, not. If a statement is always true, proposition. If a statement is always false, proposition. But if a statement can be true or false, for some reasons, it's not a proposition. So this is a proposition. Why? For any number, when you square it, it is greater than or equal to 0. Say 10 squared, 100 greater than 0. 0 squared, 0. 0 is greater than or equal to 0. -2, -2 squared is plus 4. 4 is greater than or equal to 0. You can see for any number between minus infinity to plus infinity, this is true. If something is always true, it is a proposition. But x greater than or equal to 0 is not a proposition because then for 5, yes, 5 is greater than 0. But for -3 is not greater than 0. It can be true, it can be false. So x greater than 0 is not a proposition. X squared greater than or equal to 0 is a proposition. And don't learn logic without understanding what is proposition is. So that doesn't that means you are not studying, right? Either you study in a proper way or don't study. Simple as that. Right? Questions are not propositions. A statement which can be true or false are not propositions. And opinions are not propositions because it depends on you, right? If I ask the same thing in 100 by 100 people, 100 people might say different answers. Maybe 80 people, plus 80 people says one, another 20 people will say another thing, or another few people will say another thing. Because those are opinionated. But when I say 5 is greater than 7, it is not opinion. Right? It's a fact that this is false. But when I say, right, Colombo, Sri Lanka is the best country to live, that is opinion. That is opinion. So opinions are not propositions because those are debatable, but not something like this. Right. So this is an exercise because without understanding what is a proposition, you will never ever proper understand what is Boolean logic. and digital circuit design. So which of the following are propositions? First one, when I say number, any number that you have b- play around from your grade 1 to O level, right? X is a number. This is famous notation you have learned in your sets. Kulaka, member of a number. X is greater than 5. So is this a proposition? Yes or no? Because no point moving forward without understanding a proposition. It's a effort wasted. So this is not a proposition because for some x values it is true, some other x values it is false. It's not a proposition. But second one is we already discussed. It's definitely a proposition. For any real number, it is true. Gold is the capital of Sri Lanka. Proposition or not? Definitely a proposition because this is false. Because gold is not the capital of Sri Lanka. It's a proposition. If x is a positive even number, then x plus 2 is also an even number. Proposition no, not. Proposition no, not. If it is always true, proposition. If it is always false, still it's a proposition. But it can be true or false, then it is not a proposition. Or if it is a question, opinion, it's not a proposition. What do you think? Fourth one. Is it a proposition or not? If x is a positive even number, x plus 2 is also an even number. Yes, right? If x is a positive even number like 4, then 4 plus 2 is 6 is also even, right? If you take another example like 100, then 100 plus 2 is also even. Can you find any contradiction that violate this? If you can find violations, then it can be true and it can be, or it can be false. Then it's not a proposition. But if you can't find violations, if it is always true, it's a proposition. If it is always false, it's a proposition. So this is definitely a proposition. iOS is better than Android. So that is opinion. That is opinion because it depends on the way you like it. Someone will say, I prefer Android because it has so many apps, easy to install software. There are plenty of apps supporting Android. Another person might say iOS is faster, more reliable. Yes, it's your opinion. It depends on your usage. It's not a proposition. Right. So there are two types of propositions. What are those two types of propositions? Atomic propositions and compound propositions. Atomic, you know the meaning of word atomic, atom, paramanu. So atom means you can't break it further. So that is the smallest unit of that material. Of course, you can break it into electrons, proton, but this is the smallest of that element. You can't find a smaller unit of that element. So then you call it atom. So then atomic means you can't break it further. So atomic proposition means proposition which you cannot break it further. That means you can't break it and say I have two sub propositions. If you can say like, then it is not atomic proposition, it's a compound proposition. Right? It's super easy, right? For example, when I say 5 plus 2 is 8, it's a atomic proposition. You can't find any sub propositions. And Germany won 2022 Football World Cup. It's just single proposition. You can't break it and say I have two propositions in this. But these are compound propositions. 5 plus 2 is 7, which is true, and 5 is odd number, which is true. True and true is true. So therefore, this is a true proposition. But inside that, you can find two sub propositions. So therefore, these are atomic propositions, but this big guy is a compound proposition. But all are propositions. Okay. Paris is the capital of France? Of course, yes. France is not the member of European Union. Of course, false. Because France is a European Union country. Then true or false is true. So therefore, this statement is true. If something is true, it's a proposition. If something is false, still it's a proposition. So therefore, these are all propositions, but these are compound propositions because you can find smaller propositions inside that. Now, how do we create compound propositions? By combining other propositions. It can be another for compound proposition or atomic proposition. By combining those other propositions using Boolean logic operators. Right? So when you combine propositions using Boolean logic operators, you get a compound proposition. Is it clear? But you must combine using Boolean logic operators. Just like when you combine 5 and 3 using arithmetic operator, again you get a number. Number you can add two numbers and get a number. Similarly, if you combine propositions using logic operators, you get another proposition. But if you use some other operator, no, you are not going to get a proposition. For example, you cannot say Paris is the capital of France multiplied by France is not a member of European Union. So it doesn't make any sense. Full statement because you can't add, subtract, multiply, divide propositions to get propositions. So if you want to get a proposition from those, you must use only Boolean logic operators. Sometimes you might feel it odd also, right? Because remember, sometimes you might get headache also when you study logic. What is the reason? What is the reason? So our brain really enjoy learning about your other body parts, heart, blood circulation system, stomach, digestive system, respiratory systems. But your brain little bit hesitant to learn about itself. That is normal thing, right? So we like to talk gossip about others, but it's always difficult thing is you think about yourself. Think about yourself, which is little bit uncomfortable unless you are a serious thinker. So therefore, thinking about logic is one of the hardest thing. That is why when you consider human brain, what is the part that we have very little understanding? Of course, we have very good understanding about heart, respiratory system, blood circulation system, digestive system, but we have very little understanding how brain works. Actually, if you look at the brain itself, like a picture, you will get discomfort, bit of discomfort. People hate look at brain, right? So you will feel like it's sort of a frightened because this is where all your thinking. So therefore, if you want to create propositions, from propositions, what you need to do? Use logic operators. Use logic operators. So then you get another proposition. Okay. Right. What are those logic operators? Right. Not operator, AND operator, O operator, XO operator. Nothing else. So there are some compound operators which we can build using these. So therefore, those are not basic operators. Even XO operator is not also not a basic operator because we can create XO using these three. But because XO is heavily used, we take it as a sort of a basic operator. But there's no other logic operator. If you can find another operator, maybe you will get a PhD for that. Right? If you do a research and find another operator, logic operator. These are the three basic operators, but XO is also considered that we can take it as a basic operator because it's heavily used. But actually, XO is not very basic because we can build this using other three. Okay, that I will show you later how XO is made using others. Right now, do you know what is a logic operator? So if someone asks what is a logic operator, do you have an answer? Because a lot of AL-ICT students, right, they don't have an answer if someone asks what is a logic operator is. Or they have just stories, wrong answers. So logic operator is an operator that we can apply on propositions to get another proposition. Only when you apply Boolean logic operators to propositions, you get another proposition. Otherwise, you don't get a proposition. Maybe you can apply, but it doesn't make sense. So just like plus, multiply, plus, subtract, multiply, divide makes sense for numbers like this. And or not XO makes sense for propositions. Propositions. Okay. Is it clear? I'm doing this super slowly because I told you this is the most important topic for your life, for your A level, for your career. Okay. So I'm not going to straight away start 1.1 is 1, 1.0 is 0. That is not learning logic. That is just you think about passing exams. Okay. Rather than thinking about you take control of your life, you become good geological thinker, right? Right. So there's a very close connection between Boolean logic and sets. So you have learned sets in O level, but again, I know that more than 99% of the students have no idea why did they learn sets, right? Set intersection, complements, okay? So they have no idea, but they learn it and pass the exams, like parrots, parrots, okay? It's an unfortunate reality, especially in Sri Lanka. So if someone asks, why do you learn sets? The straight answer is number one reason is you can better understand Boolean logic. So if you are very good at sets, you are going to be very good at Boolean logic. But that is not the only usage. Sets have connection with Boolean logic, relational theory, that is the theory behind relational databases like MySQL, and so on. So therefore, if someone asks for me, what is the most important maths topic you have learned? I would definitely say the most important maths topic for my life is sets. Why? Because sets is the most important topic to better understand Boolean logic. And logic is the most important thing for my life that gives me the leadership, right? Independence. So that is why your dog is under your control and not you are under dog's control. Because you are in humans are intelligence than dogs. So therefore we are going to look at or do a quick revision on sets, which you have learned in your O level under maths. We are not going to cover everything you have learned in sets, just a tiny part or very basics and definitions about sets. Because those who understand sets, they better understand logic. Those who better understand logic, they better understand their life. They take control of their life. They better understand how the computer works, how to write programs. Okay, so therefore we are going, so we must be willing to spend any amount of time to learn logic. Maybe you can say, I'm lazy to do this topic, that topic. Yes, you tell that when someone is teaching you logarithms, someone teach you trigonometry, someone teach you solving equations. Yes, maybe not only you, sometimes I also get lazy. But I will never ever say I'm lazy when I'm learning about logic because this is my life. Even when you get up in the morning, the first thing you do is process logic. Process logic. Maybe you check with you just because when you just get up, you don't know which day is right. You need bit of timing. So then if it is maybe weekday, you want to prepare for then go to the school. Otherwise, you might even think about, okay, I will stay in the bed for another half an hour. That is logic. Logic. Of course, if you make your own tea or coffee, you need to take a decision, right? Should I go for tea today or coffee? Those are all logic. Those are all logic. So then what is the connection between sets and logic? There's sort of a one-to-one connection. Those are two subjects, but highly related. If there's a concept in sets, there's a high chance similar concept in logic. Okay. Other thing is sets is easier to understand than logic because sets can be visualized. Sets can be visualized. We can say this is intersection, this is union, but logic you can't visualize. So therefore, our human brain is better at looking at pictures and understand things. So this is an opportunity to understand concepts, sets concepts, because it's easier to understand, and then you can apply that confidence to logic. Okay, so that is why we are interested in bit of sets before moving to logic. Right. So this is I told you there's sort of a one-to-one connection between sets and logic. So universal set is true. Have you ever thought of that? Empty set is false. Complement is not logic. Intersection is analogic. Union is zoologic. And if there's a rule in sets, there's a high chance there's a similar rule in logic. So there's a De Morgan rule in sets, De Morgan rule in logic. Distributive law in sets, distributive law in logic. So remember, I'm not telling that sets and logic are the same. I'm not saying that sets, every concept in set, there's a corresponding concept in logic. No, what I'm telling is these are highly related. There are plenty of concepts, one-to-one mapping. Plenty of rules. If it is available in sets, it's available in logic. Plenty of, right? Not all. And why are we interested in sets? Because it's easier to understand sets, and then you can use that confidence to better understand logic. Remember, our task is understand subjects. We are not at all worried about exams. If you understand the subject, whether it's exams or your career or your life, it's going to be a success. So people who are too much worried about exams, they're always memorizing because they have very tiny life, right? So they have very tiny scope. That scope is just passing A level. No, your objective must be beyond that. Having a good career, having a good life. So then understand logic. Okay, understand logic. Right. So therefore, let's take about 10 to 20 minutes and maybe 10 minutes and try to understand what is a set. Okay, set. I know you have answer for this, but I know that your answer is not very serious because you learn it in ordinary level. That is okay, right? Ordinary level, but now we are in advanced level. So advanced means we are more serious now. So we can look at the same thing in ordinary way and advanced way. Now we are going to look at sets in advanced way. So what is a set? Set is collection of elements having following properties. So a lot of students have no idea about what are these properties, right? It's a collection of element, yes, like say Nimal, Kamal, Amal. or it can be red, white, yellow, or it can be 5, 12, and 9, or it can be Nuge, Goda, Maharagama, and Homagam. But just you can't give something like this and say this is a set. So if it is a set, it must satisfy these three properties. Otherwise, it's not a set. What are those properties? It must be well defined. You must be able to explain very precisely what is it. Maybe you will not be able to explain what is this. Right? Even I don't know what is this. I just randomly give some numbers. But if I say A, E, I, O, U, that is a set. That is well defined. Why? These are the vowels in English. Vowels in English. So likewise, it must be well defined. You must have very specific definition of your set. You can't say it's something that came to my mind. No, then it's not a set. So if I say Nuge, sorry, Colombo, Kalutara, Gampahai, maybe it's a set. If you have definite answer, I will say yes, those are the district in Western province. It must be well defined, no specific, and no duplicate elements. The moment you see a duplicate element, you can say that it's not a set. For example, if I say 5, 2, 5, 8, this is not a set because same element can't be repeated in a set. That is how you define set. And the third one is order of the elements must not be important. If someone says order is important, definitely that is not a set. That is not a set. Now remember, we look at sets at advanced level. Why are we interested in sets? Because it facilitates you to better understand logic, proper understand logic. Otherwise, it will be like you are like a parachute, right? Fallen into ones and zeros world. So then you will get confused, obviously. Right. So these are some examples of sets. But you must have a proper definition. Maybe I can say integers between 1 and 5 is a set. Of course, order is not important, but when you write, you need to write it in whatever order, right? But I have not mentioned that order is important. If I say order is important, that is not a set. Say students in our class, assume we have 4 students, it's a set. Vowels in English language, it's a set. These are not sets. You can clearly see the duplicate elements are there. The moment you see duplicate element, you can say it's not a set. Okay. The moment you see that the order is there, like level 1 to level 2, level 2 to level 3, it's not a set. And the moment you see something like ascending order, descending order, it's not a set. Because order must not be important. And if it is not very specific, like 3 random numbers, no, those are not sets. Because if I ask 3 random numbers, 10 people will give me 10 different answers. So then how can it be a set? But if I ask vowels in English, if you know English language, everyone will give me the same answer. So that is what is mean by very specific. Right. So now you know very seriously as advanced level student what is a set is, not as ordinary level student. So let's look at universal set. Why are we interested in universal set? First of all, because universal set is has the same or similar meaning as true in Boolean logic. That is why we are interested. Okay. So what is universal set? Again, a lot of students give wrong answers, incomplete answers. For a lot of students, universal set is set containing all elements, which is utter lie. Utter lie. Okay. Universal set is not set of all the elements. So if it is set of all the elements in the world must be inside that. all the elements in the universe must be inside that, right? Because if you say universal set is all the elements, okay? If universal set is all the element, then if I have in our house, if there's a knife, it should be also there. In our house, if there's a pet like a dog, so that dog must also be there because if someone says universal set is all the elements. So therefore, universal set is not all the elements. If it is all the element, we won't draw this because outside this there can be element. So then what is universal set? Universal set is set containing all the elements of our total interested context. So that means beyond that we are not interested. That's it. Of course, there can be elements there, but we are not interested. We are interested only this. So that is why we draw a rectangular shape. So that is our interest. Beyond that, we are not interested. So that is called universal set. We usually represented by capital E. And in Venn diagram, remember Venn is another British person, mathematician. So we use his name as a credit to his work. So in Venn diagram, we show it like this. But remember, if it is the universal set, all your sets must be inside that. Because this is your interested total context. So if there's something like this, definitely this is not your universal set. That or you have selected a wrong universal set. So all because if it is your interested context, and if you are interested in this set, how can we have elements here? That means you have not I marked your universal set properly. Is it clear? So we are very serious now about logic. Because the more you serious about logic, the more you are a logical thinker, critical thinker. The more you take the independence, control. Okay. Still, I can remember when I was in grade one, two, three, my parents never allowed me to come home alone. They never allowed me. So either my mother come to collect me or someone else come and collect me. So why? Because at that time, my parents thought I am not good enough. I am not logical thinker. I may get into a different bus. I may not have logical thinking to when the proper halt to get off. But I can remember from grade six, I managed to go to schools alone. It was a different school about 10 kilometers away. But so that means they had the confidence that, okay, this guy has the logical thinking now. This guy can go alone and come back. This guy will not get into wrong bus and ended up in Candy or Goal. This guy will not get into accidents. This guy has the logical thinking to understand that when there's a vehicles coming, you should not cross the road. But you know that we don't send our dogs outside, especially if you are near a road, because dogs, most of the dogs, they don't have that logical thinking. When there's a vehicle coming, they just cross. Simple as that. So therefore, be serious. That is part of being logical thinker. Okay. So therefore, now be serious and define what is universal set. A set having our totally interested context. We are not interested outside that, but then all your sets must be inside that. That otherwise you have not defined it. Right. Second concept. So therefore, universal set is something you can decide. We just agree. Say we have different sets. Say A-level students at Aurora, FIT students at Aurora, BIT students at Aurora. So then someone will ask, what is your universal set? Possibly students at Aurora, because then all the students belong to that. But it is not all the elements in the world, right? It's not all the students in the world. So that we need to We need to agree. There's nothing called this is the universal set. It's just you and I, right, need to decide using our common sense. Okay, right. So the next concept is null set. Remember, universal set is true, empty set is null set is false after sometimes. So empty set is in Sinhala we call it Abhishunya Kulake. So empty set means set having no element. If you have a set but no elements, so then you call it empty set. So then someone will ask if there are no elements, is it a how can it be a set? How can it be a set? So then I will ask back, then how do you have a number called zero? So just like 1, 2, minus 3, minus 5, 10.5, half. So if so this is a number. Do you agree that this is a number, right? If you agree that this is a number and you use it for say arithmetic operations, so why can't I have a empty set? Okay. So so remember you must always question, and also you must prepare to answer if someone question you. Whenever you tell something, right, you must ready to give a proper reason, logical reason. Otherwise, you are afraid. You are afraid. Always you are afraid because you don't have a logical reason, right? But if you do only logical things in life, if you when you learn something, always you ask what is why. Then you don't worry, right? You don't worry about going for interviews because some people very afraid, right? Really afraid to go for interviews because they are not logical thinkers. They have just memorized things they don't understand. They have memorized things without looking for reason, logical reason. Right. So therefore, what is empty set? A set having no elements. Right. Simple as that. So that means there must not be any elements. For example, I can say integers between 1 and 10, 1 and 5. 1, 2, 3, 4, 5. Then what about negative integers between 1 and 5? If someone asks what are the negative integers, if I ask what are the positive integers between 1 and 5, this is. Then what are the negative integers between 1 plus 1 and plus 5? I will say it is this. No element. Oh, I can say it is 5. That is the symbol we use because there are no elements in that set. Is it clear? And later you will find that whatever the rules available for sets which involve empty set, there will be a rule in logic and empty set will be replaced by false. It's a very interesting topic, very interesting subject. Right. So now we are into the set operations, of course, set operations and logic operations. Because if there's a set operation, there's a high chance there's a logic operation. So therefore, we'll take the logic operators. What are the logic operators? Boolean logic operators, not and, or, XOR. So then for every logic operator, there will be a corresponding set operator. So therefore, we are going to look at both together. Why? Because sets are easier to understand. Logic, somewhat difficult to understand. But then when you relate sets and logic together, you will better understand logic. Right? Here we use sets as a supporter. Right? What is not operator in logic? Right? For example, I can say 5 is greater than 3. And we know that that is true. Yes, 5 is greater than 3. But if I say 5 is not greater than 3, if this is true, this is false. Right? I can say 3 is greater than 5. So that is false. Then if I say 3 is not greater than 5, then it is true. If original one is false, When you apply not, it is true. When original one is true, when you apply not, it is false. Do you agree with that? You need to think about it, right? Don't accept because I'm telling it. So when I say sun rises in the east, it is true. But if I say sun does not rise in the east, that is false. If original one is true, the second one is false. So we call it the not operator in Boolean logic. Like not operator in Boolean logic. Negation, invert. If the original proposition is true, when you apply not, the new compound proposition is false. If original is false, now this is true. So therefore, the truth table for not is, if original is true, not A is false. These are all propositional variables. The good news about propositional variable is it can take only two values, true, false. But if I say x, x can be 1, x can be 2, x can be -3. But if it is a propositional variable, it only two values are true and false. So if A is true, not A is false. If A is false, not A is true. Is it clear? I told you that we can always relate logic with sets. So if logic has operator, there's operator in sets, or you can explain some similar concept in sets. So in log sets, it is called complement operator. A, this is belong to A. Then what is A complement? Not belong to A. You can see the word not. Not belong to A. That is this. But I can't draw like this because we are not interested in belong beyond our universal set. Universal set is our total interested context. So therefore, not A is not belong to A but belong to the universal set. So that is called not logic. You can see the word not be used, right? Not belong to A. Right. If you have any question, you need to ask. Now I will speed up, right? Because now we have discussed about what is logic and so on. Now I'm going to speed up. Right. So this is an example. I am married. If it is false, I am not married. It is true. If it is true, I am not married. It is false. Okay. Right. Now we move on to AND operator. AND operator. This is the symbol we use in maths. This. But later we will use dot when we change from true false to 1 0. But be patient. Let's understand and go there. Right? It's always worth spending time to understand something rather than hurry it and start memorizing the things that you can't defend. How do you know that you understand or not? Say someone will say, no, I have understood. So then question him, ask why. Then he will say that I haven't understood. How do you check whether you have understood or not? Right? How do you check you understood or not? There's one word, whether you understood or not, understand or not. There's one word related to this word. What is that word? Can you guess? Can you guess? What is that word? Related to understand. Remember, when it comes to exams, there are two words. Exams. Two words. Of course, there are multiple words, but one is remember. Do you agree that without remembering certain things, you can't go and pass exams? For example, in the exams, they will ask, what is the say O-level exam, right? Uh, what is the capital of German, right? What are the parts of important parts of digestive system? Remember, remember. Okay. What is the atomic number of nitrogen? Nitrogen පරමාණු අංකය මොකක්ද නේ? Remember, right? So then understand. Have you understood the concept? So then, of course, can you apply it in real world things, problem solving? That is what they are going to do in your A-level ICT exam also, right? In any exam. But some subjects, it's heavily this-oriented. But our subjects are more into this, right? So still no one gave me the answer. What is the word that is heavily related to understand? Confidence. So confidence is coming from understanding, not memorizing. Remember it. So how do you check whether you have understood something? Ask yourself, are you confident about it? Are you comfortable to face someone talking about that with you? Are you confident to go and face an interview, Viva? That is why in university level we have Viva. So that check your confidence. So confidence is related to your understanding, not memory. Because in Viva we can keep asking questions. Keep asking questions. That is to check whether you have the confidence. So that means you check whether you have understood the concepts. Okay. Right. So AND operator. AND operator. What is AND operator? It's a Boolean logic operator. And the corresponding set operator is intersection. You can see there's a very close relation, right? This is like inverted V, right? It's very much similar to intersection. So how does AND operator work? It operates on propositions. If you have two propositions A and B, we say that A and B is true only when both A and B are true. That is by definition. That is how you define the AND operator. Right? So if someone use AND operator with two propositions, the result is true only when both are true. Okay. Both are true. For example, when you go for A-level exam, they will say you need to bring ID and admission card. They use the word and. So therefore, in order to face the exam, what you need to do? This must be true and this must be true because they use the word and. If you just have the ID, no, this is false. You are not allowed. If you have only admission, no ID, still false. If you have none, still false. But if you have both, you don't need to worry because so that means you must have that sense about what is and, right? For example, if you go abroad, you need both passport and visa. If both are there, you will be allowed to get onto the flight. Otherwise, you will be stopped. Okay. Because if you don't have visa, no point going there, right? They will not allow. Of course, there are some countries you can get on arrival visa. Let's forget about that special case. Okay. Right. So that is an logic operator. Okay. An logic operator. Is it clear? When both are true, only true. Later we will use 0 and plus. Then you will learn that when both are 1 only, A dot 1 is 1. In sets, it is intersection. That is why when someone explain what is intersection, you use the word and. Belong to A and belong to B. Belong to A and belong to B. So, or else both must be true. It must belong to A, true, and it must belong to B, true. These elements satisfy that. Right, so that is called AND logic operator. Now we have discussed two operators, not AND. Next one is, now these are some examples. Right? Remember now, if both statements are true, only true. 5 is odd number, true. 5 is a prime number, true. So therefore this big statement is true. Here Paris is the capital of Germany, false. Germany is part of European Union, true. So therefore, this big statement is false because we have used an. Right, next one is O operator. The corresponding sets operator is union. And you can see there's a big connect similarity between the O operator in maths and union operator in sets. So first of all, let's look at what is union operator. Union means this belong to A or belong to B. That is how you explain it, right? Belong to A or belong to B. A lot of people explain this as belong to A and B. That means they have no idea about what their sets. They have no idea about their set, right? They are just parrots. Parrots. Maybe they have passed O level also. So therefore, this is belong to A or belong to B. This is the truth table. If at least one is true, result is true. If both are true, also true. You can say belong to A only true, belong to B false. It's true. Belong to A false, belong to B true. Yes, true. Belong to A both. Yes, true. But here belong to A false, belong to B false, so therefore false. So that is why we have not shaded it. When we say union, you don't shade this part. So look at it very seriously. Look at it very, very seriously. Like a lawyer, like a judge. Right? So if someone asks who rule this country, of course, this government we have a lesser number of lawyers, but in other governments we had so many lawyers. So the main reason I told you, those who know logic rule the world. So what is the main subject of lawyer? Don't tell that their main subject is law. No, their main subject is logic. So that is why when you have an issue, you send your lawyer rather than you go there. Not because you don't know the law, but because you are not comfortable with logic. Maybe whatever the things in your mind, you may not be able to proper express it because you don't have understanding about logic. But after learning logic, you will find that in certain cases you can go to the courts to defend yourself rather than you send your lawyer because you will learn logic more than lawyers because lawyers what the logic lawyers learn is lesser than what we learn because computer is the ultimate machine for logic processing. Lawyers has no idea about the complicated logic that we learn in this A-level ICT. Okay, simple as that. So after some time you will feel like you are not afraid of lawyers. Because some people they are afraid of lawyers. Lawyer can go on why? Why? Because they know that lawyers know better logic than them. But you will not get into that kind of a situation. You will feel like you are a smarter person than lawyers. Of course, if you learn it proper. Right. So therefore, what is the truth table of O? When at least one value is true, the result is true. When both are false, only false. Now we have discussed three logic operators, not, and, or. Okay. So these are some examples. Okay. For example, someone will say you need passport or ID. Say you have passport but no ID. Fine. You have ID, no passport. Fine. You have both. Fine. You have none. Now you are in trouble. Now you are in trouble. Why? It says passport or ID. So when both are false, you are in trouble because it doesn't say passport or an ID. Sorry, it doesn't say passport and ID. Okay. Right. So now we have discussed not and or. Our final operator is XO. This is the funny guy. Funny, interesting operator. And first of all, this is not a basic operator. right? Because we can build this using other three operators. But you can't build and from, not, and O. You can't build not from and O. You can't build O from and not. But you can build XO from other three. So therefore, in very serious sense, XO is not a basic operator. Then why are we interested in XO operator? Because it's very widely used, uh, right? Operator which is very close to a basic operator. So therefore, we are really interested in XO operator, and therefore we will take it something like a basic operator. And digital circuit logic, you will find that we have a separate symbol for that, like this, separate logic symbol, and so on, because this is so important. But this is not a basic operator. Okay. I told you this is the interesting guy. So why is it interesting guy? Now logicians are really serious about XO. Now, with especially with computer science and so on. Very serious. But funny thing is, in human civilization, right? Remember, humans evolved in different civilizations: Greek civilization, Mayan civilization, Roman civilization. Then the people in the West, then the people in Africa, Asia, China. So we evolved sort of independently also, right? That is why we have different languages, right? Chinese people speak Chinese, Japanese people speak Japanese, Sinhalese, Tamil, French, German. Middle East, they have different languages, Arabic. So why do we need language to express our ideas, which includes logical concepts as well? And almost every language, we have words for not. In Sinhala, na, no, right? English, no, not, and in singular, saha, oh, ho. But most of the languages, not only Sinhala, Tamil, or English, there's no word for exo. There's no word for exo in English, French, Chinese, Japanese, Sinhala, Tamil, Arabic, right? Because not only one nation, everyone as humans, we were not very serious about logic uh, at that time when the languages were evolving, and especially we all of us were very casual about exo. But then when it comes to designing computers, evolution of computers, and as a maths subject, all of a sudden, like Boolean, Venn, De Morgan, so these guys start thinking about, and they found that there's another operator, which is very serious, which we need to give a lot of attention, and they call it EXO. Though even English language, we don't have a word for that because not is there in the English language, and is there in the English language, or is there in the English language. Not only English, Sinhala, Tamil, or whatever. But there's no word called EXO in English. And to that logic, there are no words in our languages also, whether it's Chinese, Hindi, Sinhala, or Tamil. But because it's a very distinct logic, they call it EXO. They call it EXO. And how does EXO logic work? It's very close to O, but not O. Not O. Remember, in O logic, when both are true, also it is true. But in EXO logic, when both are true, it is false. When both are true, it is false. Otherwise, it will be O. That is why we say exclusively O. Exclusively one value must be true. Then other one must be false. Exclusive one value must be true, other one must be false. You can't have both true. And of course, you can't have none. And logicians call that exo. And this is the truth table. This is the truth table. And we have a symbol in like this also. And logic symbol like this, or digital circuit symbol like this. So this is the truth table. Okay. So you must understand that this is not O. So then someone will ask, why are we interested in XO? So the simple reason is for hundreds of years, almost all the human civilizations have been using the one word for both O and XO. That is a tragedy actually, right? That is one of the bad thing about our thinking, human thinking. We have been using these two logic, using one word. If in English, for the both we call it O. In Sinhala, for both of these we call it Ho. For example, when we say you can bring ID or passport, it's really O. That is why when you bring both, still it's valid. Though it doesn't make sense, still it's valid. No issue. But sometimes when we say O, what we really mean is XO. For example, when I say bring me a tea or coffee. So now you bring neither tea nor coffee, then I'm upset. You bring coffee but not a tea. Yes, I'm happy. You bring a tea but not a coffee, I'm happy. You bring both. No, I'm not happy. Because when I say oh, I mean XO. I don't expect you to bring both tea and coffee. Actually, I'm really upset about that. Because when I say oh, what I mean is XO. When your mother says bring anchor or ratti. Okay. So anchor or highland, if you bring both, she will be really up, right? Unhappy, right? Because yes, she said oh, but what she mean is XO. So therefore, when we say oh, sometimes what we mean is XO. But when it comes to computers and so on, we can't say when we say oh, sometimes we mean XO, right? To computer, that computer is also become like humans, unreliable, fussy. So therefore, computer scientists, engineers came up with a different word for this, different symbol, different truth table, and formalize it. So therefore, even when you write programs, say Python, Java, you have the AND operator, O operator, not operator, you have the XO operator. So that means in English there's no XO, but in Java there's XO, Python there's XO, in electronic there's XO. You can go and buy XO logic gates in an electronic part shop because now we have it's a mistake in human civilization, but not in computer science electronic. We have fixed it. We have fixed it. But still in our languages, we use O for both O and XO because languages are used by ordinary people, right? Not only by engineers, scientists. Okay. So now someone will ask, do we have corresponding concept in sets? Yes. So this is XO. Exclusively belong to A or exclusively belong to B. This part is not there. We need to take out that. If we take this also, then it is O. Okay. Right. That's it about logic operators. Any questions? So I told you that this is not a basic operator because you can write it using other operators. For example, I can write XO using and, O, and not. This is belong to A and not belong to B. That is this side. Belong to A and not belong to B. Or belong to B and not belong to A. That is this side. You can see that. You can tell XO using this. It's something like telling, bring me a tea and not coffee, or bring me a coffee and not tea. That is the long way of telling, bring me a tea or coffee. Bring me a tea and not a coffee. Bring me a coffee and not a tea. Or bring me a Ratti and not anchor, bring me anchor, or bring me anchor and not Ratti. Because otherwise, if it is or, remember, this is also okay. So that is why I told you that XO is not really a primitive gate because we can build it using other operators. Oh, okay, got it. So now you must have very good understanding, and understanding means confidence about Boolean logic operators, right? What is logic? What is formal logic versus informal logic? Informal logic is used in religions and other people, right? Primitive people. But scientists, engineers, doctors, we use formal logic. And formal logic, we identify Boolean logic and probabilistic logic. And now we are 100% into the Boolean logic. And then we look at the connection between Boolean logic and sets, right? And now we have found that there's one-to-one connection between operators also, other than universal set and empty set. You will see the connection between universal set, empty set, and true and false when we move on to our next subtopic, Boolean logic rules. You will find that whenever there's a set rule, there's a Boolean logic rule. Okay, so there you will see that true is universal set and false is empty set also, right? There are interesting things in the next session. Okay, right. So any questions up to this point? So because we have done a very important part. Okay, any questions? Right. So it's 5:39. So today I want to stop a little bit early. Actually, uh, I wanted to start the representing decimal numbers, but it looks like we don't have enough time to finish it. Okay. Uh, anyway, so therefore I will take another 10 minutes to give you a little bit of understanding about Boolean algebra. And next class, we will, because now we have started logic, we will concentrate 100% on representing decimal numbers in computer. Okay. So otherwise, we will not be able to finish it. Okay. Right. Right. Boolean algebra. So you know what is algebra is, right? In algebra, important part of maths, we have algebraic rules. Some rules. For example, you know that x squared minus y squared is x plus y into x minus y. It's a rule. And you know that x plus y is same as y plus x. That is why you say 5 plus 2 is same as 2 plus 5. And you know that xy is same as yx. And you know that x into 0 is 0. Okay. You know that x plus 0 is x. So these are algebraic rules. These are algebraic rules. This is not Boolean algebra. This is arithmetic, maths, mathematical algebra related to numbers. And there are some more, right? X plus y squared is x squared plus 2xy plus y squared. So similarly, in Boolean logic, we have this kind of rules or axioms. Axioms means obviously true. You don't need to even prove it. How do you prove it? You think about it and you will find that yes. So can you prove that x plus y is y plus x? No, right? But your logical thinking says yes, it's correct because you know that 5 plus 2 is same as 2 plus 5, or 2 plus 3 is same as 3 plus 2. You start with two fingers and open the other three fingers. Now you have opened five fingers. You start with three fingers and now open the other two. Now you have five fingers. So if you want to prove it, that is actually the way to prove it. That is why we call them axioms, pratyaksha, right? Or we call them rules. So in Boolean algebra also we have that kind of very obvious rules, axioms. And those rules we discuss under Boolean algebra. So there are about 20 odd rules you must know. First, we will look at it from normal Boolean algebraic notation. Then we will look at the set notation also because I told you it's easy to understand set. Remember, your task is not memorizing rules without understanding. Why? Memorizing doesn't give you the confidence. Understanding gives you the confidence. Simple as that. Right? Memorizing may pass your exam, but it may not pass your life career. So therefore, we'll do it in a very slow manner again. Okay. Right. So there are 23 rules. There are more than 23 rules, but these are the major rules. And the good news is in Boolean algebra, there's a not only Boolean algebra in sets also, there's a duality principle. Duality principle means when there's a rule, there's another corresponding rule. When there's a rule, there's another corresponding rule. But it's not always, but most of the time. So therefore, in reality, though we call it 23, finally you will find that this is about 12 rules, 12, 13 rules, because most of the rules are duals. So therefore, when you know this rule, you can just write down the other rule. So therefore, when you write down about 10 rules, you can write down the other 13 rules and say these are my 23 rules. So therefore, don't worry. You don't need to memorize 23 rules. Actually, you need to remember about 10 rules because others are it's dual, but not always in some cases. Okay. So that is a good news. If you are afraid of memorizing 23, no, it's going to be just about 10. And some of those rules are something like A plus B same as B plus C. Obvious things. That is, I told you these are obvious things, right? So that is why in Sinhala we call it Pratyaksha. Right. So that is a duality principle. So these rules comes in pairs. Not all the rules, some rules. So then how do you decide which rules has a pair or duality which is not? Very easy. Uh, if you have intersection or and become O, true become false. Do not change not. Okay. For example, there's a rule called A and B is same as B and A. So its dual rule is remember we have and become O. A O B is same as B O A. Why? Because this is the dual of this. This is the dual of this. For example, De Morgan rule, we have the two rules. One is the dual of the other. So how do you get the dual? Change and into O into and. True into false, false into true, but don't take not. And later, rather than and, we use dot. Rather than this, we use plus. Rather than true, we use one. Rather than false, we use zero. But that is later, right? Because we are not worried about memorizing things. We are worried about understanding things because understanding gives you the confidence. Memorizing gives you headaches, right? Memorizing gives you headache if you try to memorize things you don't understand. So if you are confident, you are a very happy person. That is another advantage. I don't know whether you have seen our website. You can see. Less memorize, more understand. So more understand means you are more happy. Why? You are more confidence. You are more confidence. Okay, so that is our philosophy and our study model, right? Right. So what are those rules? So these are the rules. So this is just for you to have a glance of it. These are the set logic rules. These are the corresponding set rule. I told you that for a set rule, there's a logic rule. For logic rule, there's a set rule. There's a very nice connection between sets and logic. That is why we discuss about what is a set, what is universal set, what is empty set, what is intersection, what is union. Why? Because we want to understand rather than memorize. So then you will have better confidence about maths. better confidence about logic, better confidence about how the computer works, because you know how these things are interrelated. So don't worry too much about these rules right now. This is first set of rules. You can see most of the rules comes in two pairs, but not all the rules. For example, this guy is a single rule. And this is the second part, another set of rules. All are duals, right? Pairs. And this is another set of rules. But here, sometimes you don't have a dual. For example, this one you don't have a dual. Here you have a dual, but we are not interested in the other one, right? Interested because this is the most widely used one. Okay. So that is why here we have isolated three. But actually, these three also have duals, but we are not interested in the dual. Okay. It looks lengthy, but once we understand, we move on to a short notation like dot plus 10 notation. That is after understand. That is good for memorizing. But we are now in the stage of understand. Once you understand, you memorize it using dot plus, yes. But we are not going to understand using dot plus because dot plus 10 is for computers. You guys are humans. You guys can see sets and understand what is intersection. You guys can understand what is true and false, right? You guys can't understand what is dot and plus. Of course, even I can't understand. I can understand after understanding true false because then I know that unconsciously when I see dot, I know that this is an. When I see plus, I know that I will use my understanding about O. So therefore, let's not worry about dot and plus. Let's really serious about and or not exo here. Okay. So these are the rules. Okay. So we are going to look at one by one. Right. Right. We are going to look at those rules in the next class because I want to stop a little bit early today. Okay. Uh, right. We are going to look at those 23 rules. Not next class because next class we are going to maybe next class we can take first hour finishing our representing data, and if we have time, we'll get back to this. Okay, right. So we'll stop a little bit early today. Okay, right. If you have any questions, you can ask. Okay, you can put it into the chat. Right, we stop at this point. Right. Thank you.